Hi there, my name's Vince from mymatevince.com, and do you remember the PlayStation 3 that I had trouble with where I couldn't update it because I took out the Wi-Fi card, and basically when I tried to update it, the PlayStation 3 checks, I think, for different things to make sure they're connected, and because it couldn't see the Wi-Fi card, it kept failing the update. So, although I fixed the problem of it not being able to turn on by removing the Wi-Fi card, it no longer is actually usable, even though it is working. So yeah, I left it at that because it wasn't really worth spending any money on a PlayStation 3 because you can buy them very cheaply. But a lot of people in the comments said, yes, it's not worth it for the purpose of the value to resell it, but it's worth it for the YouTube video. And I thought, well, actually, that is very true. So I did have offers of help. Thank you very much. But I opted before that, even before reading those messages, to just go onto eBay and buy what I need to buy. So I bought myself a new little Wi-Fi module, even though this does look slightly different. It says in the listing that it's suitable for the Series 3000, which is what this is. And I also bought myself a little hard drive because it was only £9.50 for 320 megabytes. Now, the main reason that I went ahead with this revisit is because I had one very simple comment that I think is a really, really good idea. Now, if I try to fit this on here, I'm going to have to use a load of heat from above, or possibly I could try to heat the board below. That is an option. But the thing is, I haven't got a proper board heater and stuff. It's not the right way really to do it just by blasting the heat at the top. Chances are I'm probably going to damage this chip in the process. But how about, like the comment said, I attach it just with wires, and then if I want I can always unsolder it again after it's updated, and this can be an offline machine. So that is exactly what I am going to do. I am going to put little wires between the balls here and the balls here. Now, the good thing, I was chatting to Chris from Gadget UK 164, and he said that you won't need to do every single ball because have a look there. Most of them are actually ground. So I'll only need to connect a couple of ground wires. These are basically here to add strength because the more ground you have, the less chance you have of this falling off. So I've counted, and I think I'm only going to need to do 23 wires max, but even less than that, because if you have a look on the opposite side here, a lot of these ones that go through these wires are all on the same little rails anyway. So for example, that 1, 2, 3 there, which correspond to, I can't remember where it is now, but there's, see these ones down here, or the ones here, these three here, I think it might be 1, 2, 3, they're going to be joined. There's ones up here, 1, 2, 3, that are joined as well. So basically I'm just going to do the minimum wires possible. Also, it looks like some of them don't do anything at all. So some of them kind of go up to these wires here, and I think they're just for test points. You see these ones up here? But rather than spending ages trying to trace every single one, I am just going to put the wires to here, which are not ground and which aren't obviously in common with each other. So yes, it's probably going to take me a good half an hour to 1 hour, but at least then I know that hopefully I will be able to get this working. And then if the short persists, I will be able to get my probes in there and see exactly which wires are shorting together. And again, it will give me more info as to what is exactly causing the problem on here, or whether somehow it's going further into the board. So I think that's a really good idea to do it with the wires. So yeah, that's what I'm going to do now. I've gone about this the wrong way, haven't I? I should start with the short ones here and then get longer and longer, otherwise I'm going to get in my in the way massively. So I am actually going to unsolder these up here, and I'm going to start at the very short row. Right, just a quick update. Now, it's taken quite a long time. I think I've already been at it for probably about 20 minutes. Realistically, I think this is going to take another about half an hour to 45 minutes from here. But if you have a look, I've only got the one ground wire at the moment in the corner. But now look, if I go ground from the main board, look how many things on here are grounds. So you can see that the majority of them are actually ground. So obviously it makes the job a lot easier than having to do every single one. Now I am tinning each of the wires, but I'm just doing it off camera. I'm just doing it here. So yeah, each of the small little wires that I cut down to size and strip to get to the conductor on the inside, I am then tinning. Look at that, I'm quite proud of that. Now I could spend a bit of time getting them all nice and straight and aligned and stuff, but I think it's alright. They all seem to be on there. I don't think I've missed any of them out, so if we go to continuity, a lot of these empty ones are just ground. Ooh. Oh, okay, that's fine because look, that's on this rail here. Hold on, where's that rail gone? The red one here. There. Yeah. So, I think that's going to be alright. Now, in hindsight, I'm thinking I should have done this. I'm wondering now, that's going to get in the way, isn't it? That's going to get in the way of, did you know, I didn't even think about putting the metal thing on top of here. Oh well, it is what it is. Basically, we just want to get it together to work. Part of me's thinking if it does work, if it works, then I'm wondering if I could just leave it like this. You know, I wonder whether this would cause interference or not. I know it's a complete bodge job, but I'm just really apprehensive about putting so much heat on this thick board, because I could leave it like this, and then in the future, if I get myself a board heater, you know, like a big slab, like a flat oven thing that I can place it on and it can put all the heat into the board, then it might go a lot easier by just putting a little bit of air on the top rather than having to put the extreme amount of air that I did before. Anyway, that's jumping ahead of myself. Let's see if this is going to work. So what I'm going to do is I'm going to flip this over. Let's see if we've got that short now that we did before. So it was short in between this capacitor up here, wasn't it? No. Excellent. Okay, so it's definitely not shorting. Right, I'm going to try and put this back together. It might take a bit of time. Now, if you're wondering what wire I used all different colours here, and it is called it's basically American wire gauge 30, and I just bought it off eBay in 5-metre lengths because that's going to do me absolutely ages. They're only something like $1.99 per length, if that. I think this whole and I think it was buy two get one free. I think this whole lot here cost me about £9 UK. So yeah, I've got it in different colours, and it's 30 when it comes to the size. So obviously it's absolutely tiny. Right, so what I've done is I've put a little bit of a kink in the metal tray here. It can always be folded back down again. And I've just basically put Captain tape to stop this shorting against all the wires there. So now I'm going to try to piece it back together, not properly. You can see I've got the surround of the fan off because I was thinking I might just put the heat sinks on, but they're riveted to this thing here. So remember, I just want to see if it's going to work. Right, I've just had to put the top cover back on and put these two screws in to try to squeeze down this side, because obviously the whole thing's kinked up and the power supply, the two 12-volt prongs, are no longer making the contact with the power supply from the motherboard, the prongs from the motherboard. So by doing that, I'm hoping now it will squeeze it all together. Right, let's bring this over to the TV and let's see what it's going to do. Right, this is interesting. Look, as soon as I plug it in, we get a red light, but then it goes out again. Yeah. So that makes me think that that Wi-Fi board is shorting again. It must be where I clamped everything together. I'm going to have to work out a way I can do this when it's all apart. Right, now this is really interesting. So you've seen the red light came on and went out again straight away. Well look, I've taken everything off and now we have a short again. So there's no shielding on here. I thought the shielding would have been just maybe shorting against one of the wires, but look. So it's like when we put any bit of power into it, we have a short. Look across the capacitor, shorting. And along that rail, just like before. So what is causing that? I've wiggled all these wires. Just lift them all up. Oh, that's shorting. Right, so what I'm going to do is I'm going to find the rail which is shorting, this top one here, because let's have a listen on this one. No, that one's okay, so it's this one up here. And let's find out, so that's the top one. So it looks like it is this one here. Sure enough, that red one is shorting. Why? Let me get my soldering iron back on. I'm going to unsolder that red and then see what's happening. This actually might be quite useful because it might tell me what was wrong with the other one. Maybe it's something on the board. That's would it be putting too much voltage into this and then damaging it or something? But saying that, I didn't even turn it on, did I? It was only the 5 volts that was lighting up the red light. Unless maybe this isn't designed to have 5 volts. Who knows? Right, now let's see what's happening. No, so look, it's the Wi-Fi card. Look, the board isn't shorting there, but when I go onto the red wire here, it's the Wi-Fi card. So somehow it looks like I've blown the Wi-Fi card already. Because this is exactly what happened before. These ones here are shorting. So look, if I was to pick a ground at the corner and go on to, let's move these out of the way, and go onto this rail here. I know you can't see any of this. Let me zoom right in. Right, okay, so I'm at the corner and look, can you see it's shorting on this rail? And it shouldn't be. It's 1, 2, 3 of them. And where else do they go? Nowhere. Is that pad lifted there? Pad's lifted. But look, it's still shorted here. I've got a lifted pad there now as well. Oh, I thought this was going to be straightforward. Look, there's nothing. Look, can you see there's nothing here? So that's definitely inside, isn't it? Right, now, rather than messing around with this one, I think I'm going to look at the old one and see where these go to on the other side. Look, there's nothing there, nothing around there. It's full on shorted there, which is exactly what happened before on that same rail. What is it on the board that's causing that to happen? So you've seen beforehand there was no short, but as soon as I connected to the power supply, then the red light only came on for a couple of seconds, went off, and that was it. But what's different this time is the red light is coming on for a couple of seconds, while before I don't think the red light came on at all. I'm going to get the other one out and see what that rail is. For a spec sheet of that main chip in the Wi-Fi module, the Marvell chip, and at this moment in time I can't find it. But what I've done is to me it looks like that main chip is shorting. So I'm wondering if I can find a spec sheet, maybe I can find out what the voltage is feeding that. Because remember, as soon as I connected to this one, and I know my wiring's a mess, but I'm pretty sure there was no of the live dots connecting with any of the ground pads. As soon as I connected it, then the red light went out. So that says to me that maybe if that chip can only handle 3 volts and there's 5 volts or something going into it, maybe that's why it's blowing. So right now I've just connected it up. You can see I've got a little red light here and I'm just measuring for voltage. So basically, if you have a look at my meter, you can see I'm using the ground here. And on this rail up here, so remember we've got it desoldered now, that wire, I have got only 1.8 volts, which doesn't sound a huge amount. I mean, I don't know what the chip is supposed to take, but that says to me that it's 1.8 volts. On top of that capacitor, 1.8. That side, nothing. This thing next to it, not sure what it is, 1.8. 1.8. Feeding this little chip, I think, was 3.3. There you go. So it looks like that little chip here is, I'll zoom in a minute and show you. It looks like that little chip is moving it down from 3.3 to 1.8, and that goes to what I think looks like a transistor, and this side of it is 3.3, and going into this transistor is 4.7. And yeah, on these vias here we're going to have 5.5. So it looks like it is working its way down. Now let me just show you that path I was taking. Right, so it starts at these vias here at 5.5, and then it works its way up to this, let's call it a transistor. That part there is 4.7, this part 3.2, this part 3.3, and then from there it travels up all the way along into what looks like this part of the chip, and here we have 3.3 going into it. Yeah, 3.3, and then coming out, which I think is this one here, we have 1.8, 1.8, 1.8, 1.8, nothing, nothing, and that would be 1.8 as well. So I need to find out about this chip, because let me just show you the chip now to show you where I think it goes to. Okay, and now just out of curiosity, before I show you the chip, can you see now I've got the green light, so I've turned this on. Now I'm just going to quickly whiz through and see if the readings are the same. 5.5, now I'm going up to that transistor. 3.3, 4.6, 3.2. Let's move up into here. Right, it's shut off because it's overheated. Yeah, it's overheated because I've got nothing on the chips. Let's try it again quickly before it overheats. Yeah, 1.8. 1.8. So, yeah, even when it's on green it says 1.8 there. So that says to me that that chip is always 1.8 whether or not the console is on or off, which doesn't seem a huge amount to make it blow. Let me get a little Wi-Fi chip, the old one, to show you where it went. Right, okay, now remember these are shaped slightly differently, but look, when it's on the board it's like that. So now when you flip it up this way, the ones we're looking at are these three contacts here. So these three are basically shorting to ground, okay? So let me get rid of the board now and let's just work on this one, because there's exactly the same fault between both of them. So now if I go to continuity, you can see with this one here, if I go between here and here, it's shorting, yeah? And it shouldn't be. Now if we flip it over, it's very hard to see where these actually go to, but if you look, it's somewhere along this area here. Yeah, I can't really trace the vias, it doesn't seem to make any sense, but look, if I go between here and here, can you see that this capacitor is shorting? And if you look at this chip, this corner is shorting, which might well be normal, that might be the ground, but also look, the one next to it is shorting. And why would you have a capacitor shorting on both legs? Do you see what I mean? So one of these should be going to ground, but not both. And if I look real closely, it's so hard to tell, but I think it's really, really hard to tell. This is tiny, but I think this bottom one here goes to that side of the capacitor, that bottom leg, and then it travels down to this one here. So look, can you see that everything's short in here? So what I'm going to do is, I'm going to get some heat, I'm going to pop off the capacitor and then see if it disappears, because this big one here is shorting, but I think it's the chip that's gone. But the problem is I'm not getting any I'm not getting any info. So the chip is in Marvell 88W8781NXU2. Now we'll have another look, because if I can get the data, the pin out of it, then I can see, maybe it might even tell me what voltage is supposed to go into it, but 1.8 seems pretty low. I'm sure it needs at least that. But why, as soon as it's connecting, is it failing? Why is it, I don't see any smoke or anything. It's just the same thing's happening on both of the things. This one and the new one, but the new one I didn't even turn on properly. Right, I think I took off a little capacitor or something along with it. I'm not too sure. Now let's just see if the pads themselves are shorting. Yeah, so the pads are shorting, so basically I'm almost certain it's the chip. Let's just get this capacitor. Yeah, do you know what? Let's take off the chip and then we'll have a better idea, because surely that capacitor shouldn't be shorting. We'll take off the chip and we'll see then if the pads at the back are shorting or not, because now if I flip this over, these are the dodgy pads here, and you'll see that there's still going to be a short on them, which there is. Right, I don't care if I blow everything off the board. I'm not using flux or anything. I'm just going to take this chip off. No, I'm just burning it. I will have to get some flux. Annoyingly, I need to get something to clamp it down, because it's just the solders. The suction of the solders more than the actual weight of the board, I think. I don't really care about the mess. I want to see what's happening now on this board. Right, okay, so as you can see, the short's gone. So now I wonder, let me just work out which pins. I wonder if I can actually find the pins on here and see if the pins themselves are shorted to ground. Yeah, well, have a look here. Well, I'm just going to mess around with this for a bit. I just want to see. I can see that second pin is going to a tiny via on the inside of the chip, and I want to know if that's going through to the holes here. So I'm just going to mess around here for a bit, because if I can work out what's going on here, if it does turn out to be, for example, not the chip, then there might be a chance of me salvaging the one that I've just bought, which I haven't really even had a chance to. All I did was plug in the machine to get the red light for it to go straight away. So you never know, by sacrificing this I might be able to get the other one working. Right, I don't want to move too much because otherwise I'll lose it on this side, but basically on this side I'm on those three contacts, the ones that shouldn't be shorting, and if I go onto this bit here, then it is actually coming up on the little capacitor that's left, on the bottom of it, not the top, the bottom, and this pad here. Okay, and that also goes to number 1 of that chip, not the second one, and number 3. So 1 and 3, 1 and 3 are going to this pad here, and that's the pad that I'm talking about. The pad that shouldn't be shorting, so these 3 here, 1, 2, 3. So that says to me 1, 2, 3, hold on. So that means that pins 1 and 3 on the chip are definitely going to that rail that shouldn't be shorting. Let me just check the grounds on that capacitor. that one there, and that one there. Okay, so now if I was to go on the pad here, and 1 and 3, it's not shorting. The capacitor that's left is no longer shorting, and the pads of the big capacitor is only shorting on one side, which is correct. So that says to me, without doubt, that this chip is definitely faulty, because we have a short between here and, sorry, not that side, this side, isn't it? Between number 1 and number 3, which is no good. Now I just need to double check that this massive middle pad is definitely a ground, and it is. So 100% the chip has failed. Now, why has the chip failed? So let me go online and take a better look, see if I can find out a spec sheet for that. Right, annoyingly, when I look up the data sheets here, no matter which website I go on, I mean, I haven't spent a long time on it, and maybe I'm typing in the wrong thing, but it always says here, many thanks for your attention, and it says here, but I regret to inform you that the part number, blah blah blah, you entered is either invalid or we do not carry on our web. We will update the requested part, blah blah blah. So it doesn't look like I can actually get the data sheet off this, which is annoying because I'd like to know what voltage is supposed to be fed by. Right, what I've decided to do is, this is the other PlayStation 3, you know, the one that cuts out straight away. So basically it goes to green and then cuts out. Yeah, but remember we do have the red light. Now, I've gone through, I don't need to show you the same path as before because you've already seen it, but watch this now. Voltages are exactly the same. Because I don't believe it's the Wi-Fi module. It's something feeding that Wi-Fi module that is causing that chip to blow. I don't think the chip needs 1.8 volts. Maybe it needs something like 1 volt, something, and 1.8 is blowing it. But look, can you see on the wires here, we've got 5.5. Going up to this transistor, let's just go through all the legs again, 4.7, 3.2, and 3.3. Yeah. And then we go up to this little chip here, first leg here, 3.3 going in, and then coming out on this, whatever it is, apologies, I don't know, it's, oh hold on, yeah, 1.8, which is the same as before, 1.8 there, top of the capacitor, 1.8, 1.8 of the resistor, nothing at the bottom, and nothing there. Bottom of this thing, 1.8 again. So both boards are reading the same, yet there's obviously an issue because that part I don't believe was, look, the part's not faulty. The same thing's gone on both of them. So it can't be the actual Wi-Fi module. And it's the chip that's blown, so I can't even change the capacitor or anything like that. So what I'm going to do now is I'm going to unsolder all the wires that I soldered on, and I'm just going to make sure when that board is free from wires that it is still short in between those pads, because I know what people are going to say. They're going to say that I shorted it on those wires, but like I said, I know it's a mess, but I didn't short those wires. Those wires are okay. Unless, of course, you need more ground wires for some reason, but I don't believe that's the case either. There's something causing, there's something pushing through too much voltage onto that chip. But I can't find a data sheet, so there's nothing I can do with it, and I'm not going to spend any more money on it. Let me unsolder those wires just to double check that, and unfortunately, that will be it for the video. Right, so this is it unsoldered. That was my sticky pads on that bit there. I mean, it is different. It is different than this one here. But saying that, it definitely says for a 3000 model. And also, let's have a look at the pads at the bottom, see if they are similar. Three at the top. Yeah. Yeah, although they're a different design, they do look to be in the same place. Anyway, look, let's go between here and here. So this is the ground at the corner. You see that all the corners are ground. Now look. Yeah, and they're all shorting. Oh, what a shame. Right, what I'm going to do is I'm going to look through the comments and see who it was that suggested about the wires, and because I do think that was a very good idea. Oh god, look at this. Right, I've gone on to my video trying to fix PS3 Slim, which has no power at all. Now, I am guilty of the last few days being so busy trying to fix a PlayStation 4 that I haven't checked the messages. I did on the first few hours of this video, but not after that. Look at this video here, 3 days ago by, look, Fakult. Look at this. This is what's wrong. Oh, if I had read this earlier. 60 thumbs up as well. Look, hello Vince. I have repaired many consoles with the same glitch. This fault also appears on super slim models. The 1.8 volt regulator is guilty here. This makes complete sense, which is constantly turned on because it supplies the BT module so the console can be turned on by the controller, because obviously you can just turn on the PlayStation 3 by just turning on the controller. So the Bluetooth always has to have power. That confused me in the last video actually, why the Wi-Fi has power, but that's the reason why. Okay, it says here, first the regulator burns. This small black system near the S&D coil. Let me show you that. Right, so that must be this tiny little chip here that I was talking about. Remember this little one here? Yeah, next to this S&D, was it S&D coil? Hold on. Yeah, black is near the S&D coil, so that must be this thing here, this chip here. Okay. Which then burns the module, not always, in other words the Wi-Fi module. You can replace this small regulator with, for an example, an AMS 117, which is more resistant. I'll show you the document for that in a minute. You should check before soldering a new BT module if there is 1.8 volts on the coil, otherwise you will burn the new module. Now, okay, I agree that the module wasn't to blame, that something is to blame for causing the module to burn, but I have got 1.8 volts at that module. Not the module, sorry, I have got 1.8 volts at that little regulator. So that says to me that it's not burnt, because now when I test it, it's exactly the same as my other one. There was 3.3 volts going in and 3.3 volts going in and 1.8 coming out. It was definitely 1.8. It says here, this can be checked very simply by connecting the power supply only with a flexible cable without connecting the 12 volt line. Best regards from Poland, Fakult. Well, basically that is absolutely perfect, isn't it? That makes complete sense, apart from I do have 1.8 volts, so what's going on there? Now, let me just quickly show you that other comment before I forget about the wires. So let's go down here, highlight this comment. That's what I thought, that the always on Bluetooth Wi-Fi module could be the cause. Shermtronics, I've got a pile of 14 or 15 Slims in my loft, as well as a few boxes full of the first gen 4 USB 1. I'll dig through them this week and see if I can find one for a Rev 1 Wi-Fi card. Looks like I'm going to be needing another one if I'm going to do a revisit. Here we go, this was the one here. Now, I'm going to pronounce that wrong because I'm just useless at phonics. De Groenpunkt. One thing you might want to do is this. If you get another module, you can connect it with wires instead of connecting it directly to the motherboard. Do the installation and take it out again. Why don't you try? I think that means. And it's a great idea, great idea. Right, so see, the thing with comments is, you do know I do normally read the comments. I've got to the stage now where I'm finding it hard to reply to a lot of them because I've got a lot of videos on YouTube, and I got a lot of comments, and I was kind of spending a week doing it, so I've had to cut down a bit because I'm spending too much time working and all the rest of it. But I do definitely read them. In this instance, I'm delayed in reading them. I read them for the first, I read them that night. I woke up the next morning, I read the comments, but then I didn't read them after that because I've just been working non-stop since then. But you see, if I'd read that, maybe I could have tried swapping that regulator with the other PlayStation 3 Slim. The thing is though, I would have tested it and I would have had 1.8 volts, which is what I've got now. So that's the thing that I'm not sure about. If I was reading 3.3 volts there, then I would say that's definitely what's blown it. But this is really weird. Anyway, let me go into this document here. So I've typed in the AMS 117. Now this is the bit that I'm not sure about. What should be going in and what should be going out? Because if we look here, it says, where is it now? Here we go, look. Right, typical application, right? And you see we have 5 volts going in and we've got 3 volts going out. Now, because it's a variable one, does that mean if you have 3.3 volts going in, you're going to have less coming out? I mean, does that make sense? Can we do a calculation on that, I wonder? 1 second now. What's 5 divided by 3 equals 1.6. So let's do 3.3 divided by 1.6. Now, is that how it works? 1 second now. What's the difference between that? God, I'm useless. Right, so 5 divided by 3 equals 1.6. If it was 3.3 divided by 1.8, it equals 1.8. So they're not exactly the same. But would that be it? Do you know what? I think I'm going to have to wrap this video up because right now I'm at a loss about what I can do. If I could be tempted to do a revisit. I know I'd have to buy another Wi-Fi module. That's not really that big a deal. I think it was £12 or £13. But the thing is, this is what I don't understand. If I've got 1.8 volts on that rail, why did it blow? Do you know what I mean? Or does it surge? Is it a surge thing? As soon as you plug it in, maybe as soon as you plug it in, it goes to maybe 3 volts, then drops to 1.8. I don't know. Do you know what? I'll quickly check that now. So much easier when I don't have to worry about the 12 volt supply going in. So as you can see, I've just got the 5 volt. I don't even need to have that little thing at the front with the red light because there's 5 volts going into here anyway. Now if you have a look at this little black thing here, I'll keep it zoomed out as I have to keep it zoomed out so you can actually see what's going on. But if you have a look here now, can you see that side of the coil and this side of the coil are both reading 1.8 volts. So now what I'm going to do is I'm going to hold one here and I'm just going to hold the other one there like that so you can see 1.8 volts. Now I'm going to be unplugging it. I can't show you the plug because it's too far away, but you'll hear it. Right, so that's what it sounds like when it's unplugged. It takes a couple of seconds and it goes down to nothing. Now watch this. When I plug it in, it doesn't jump up to 3.3 volts or anything. It's just 1.8. You ready? There you go, 1.8. Now did that read 2.2 for a second? Hold on. Let's unplug that. And in. No, it's 0.22, so 0.22 is not going to affect anything. So, I mean, looking at that, it looks like it is doing its job. Because let's say now, I would, check that for 1.8, which it is, but you can see that it definitely blew the brand new, well, not the new, but whatever, it might have been a second-hand module, it blew that one and the one before. But yet, it was perfect because it was only when I plugged it in. Remember, I tested for a short after doing all my wires and there was no short. As soon as I plugged it in, I had a red light that held on for about 2 seconds, disappeared, and ever since then the red light only stays on for a couple of seconds before it goes. Unless it's something to do with when there's a load on here. So when there's if I had the module, well, there's no point because if I attach the module now, it's going to just short out because it's shorted. So that doesn't make any. I was going to say if I attached a module, I could then see maybe if it jumps up to a higher amount. Okay, I'm going to check this other rail here because there's another rail that also feeds the chips. That's 3.3, which again seems normal, doesn't it? just unplug that. Let's see if this one jumps up. No, 3.3. Unplug again. And plug in. No, 3.3. So as far as I'm concerned, that is testing okay. Yet obviously it's not okay because I've gone through the original Bluetooth module, which obviously happened before I got it. Just keep it unplugged so I don't want to get a shock off this here. And now this one here. So I'm not really sure what to do. For Colt, if you're watching this, then maybe you might know. You might say, well, Vince, no, that can't be faulty then. It must be something else. Or you might be like, yeah, but when it's connected, then, or when the 12 volts connected in as well, then that one goes faulty. I mean, I don't know. Should I go further on this? Well, I am tempted. I could do a revisit. I've got to be careful. I don't just want to buy another one of these, put it in, and for the same thing to happen again, because it's time consuming, and also I don't want to just waste money on it. But at the same time, if it can be fixed, it would be nice now to get this working, because for me it's not really just about having a PlayStation 3, it's about solving the problem, because if it can be fixed here, then it could possibly help other people fix their PlayStation 3s if they've got the same problem, because other people would have thought it was this, gone out and bought a new one, and then it might not be this at all. I mean, it could be, but in this instance it's definitely not that. It's something feeding that, which is blowing that. So I think I'm going to leave this one up to the YouTube community, and I won't jump the gun this time. I'll wait. I'm going to read all the messages now on that video, and then I'll read all the messages on the revisit video, and obviously within reason. I might not be able to read them in 6 months' time, but yeah, then maybe after Christmas I can do a revisit, order up another one of these, and then take this one off the other board, or even maybe buy one of those AMS, whatever it was, 1117, can't remember, but maybe I could buy one of them or something. But at this moment in time, that looks to be normal, but obviously it isn't normal. So it's beaten me. I don't know what to do, but hopefully you lot will know what to do. And if you do know what to do, put it down in the comments, and then I will follow that advice. And if enough people suggest the same thing, then I will do a revisit, and hopefully we might get this PlayStation 3 Slim working. So yeah, I don't think it's a waste of time. I've quite enjoyed doing this one again, because I feel like we've got a little bit further. Again, apologies for not showing you a working one, but I still think it is. I still think it's relevant, because maybe now there's more info that we can take forward and then get this working on the next video. I know a lot of people think this is complete madness over a PlayStation 3 Slim, but it doesn't matter. Even if this was a PlayStation 1, it's not the monetary value of it, it's the trying to work out exactly what's caused the problem. So hopefully you've enjoyed the video. If you have, please give it a thumbs up, and please comment down below and tell me what I should do about this. Speak to you soon. Take care. Bye now.